So welcome back, Isha. So for those of you just joining us for the first time today, as Isha was on earlier on with giving us a crypto update. So I'm really pleased to have her back with us today. So very early start for Isha. It's 6 a.m. I think now for you, isn't it?
Yes,
So,
it
is. Yes. So welcome back, and over to you.
Awesome. Thank you so much, Jamie and Sue and the whole team. So yes, hi everyone. My name is Isha Shireen Powers, and I am your resident crypto nerd here. So thank you for those who attended my session. If you didn't attend the session earlier, I love crypto, and I've been at IBM for next year. It'll be officially 20 years, and my career has been in software development for crypto and looking at compliance and looking at pervasive encryption and many different technologies. So it's absolutely been a fun journey here. So I will say, as we go through, feel free to ask questions. Feel free to introduce yourself in the chat or tell us where you're from. As Jamie said, I am in the US, and particularly I am in Los Angeles. So it is very early for me at 6 a.m. But that's okay. I'm glad I can be here and can see all of you, and that I can kind of share some knowledge about cool features related to crypto and z16 that you guys can leverage, so that you can kind of, make sure that, your data is protected and you have awareness of the protection of the data. Or if you're looking at quantum and you're trying to go on that journey and you need to build a crypto inventory, this will also help you with that too. So please ask questions, and thank you again for joining today. Okay, so z16 is built to build. And though today's focus will be, of course, on security, it's just important to look at z16 as a whole and to realize that we're also looking at as a platform at modernization, cloud, automation, AI. So there's all of these different cool technologies that are all associated with z16. And although we're going to kind of drill down into crypto and what's available, there's just a lot, to be offered, using the platform. So I hope that you and your organizations and your teams are taking advantage of all that is there. Okay, so we're going to focus on security and then the idea of this cyber resilient system. And for those of you let me actually ask a question to the audience. How many of you had attended or how many of you did not attend my previous session? I'll go there. So I know how much detail to cover and how much to kind of gloss over. So let's see. I'm looking in the chat. I don't see any.
Looking at names, Isha, I think most people joined your previous session. Yep.
Perfect. Okay, so I won't dwell too much on the details then. We'll just kind of do a high level refresher. So you guys remember this crypto skyline then. And the whole idea is that we have all of these really cool crypto capabilities and technologies that are available: application level encryption, DB2, network security, signatures, secure boot. And all of these really cool capabilities are all built on top of a foundation of algorithms, really strong cryptographic algorithms. However, over time, those algorithms that had been seen as strong at one point may not necessarily be considered strong anymore. And so you have to consider where you need to get to in the future. So maybe you were using DES previously, and now you're like, okay, well, let me start moving to AES. Or maybe you were using RSA, and now you're moving to elliptic curve. But as you start thinking about the quantum era, even those algorithms like DES, we know is going to go away. RSA, we know we're already moving away from it. But now even elliptic curve is at risk as well. So the idea is that we need to get to a position where we're on solid ground and we don't have that tilting over of the crypto skyline. So our goal is to get here, right? Where we have AES on the symmetric side, underlying all of those symmetric capabilities. And then we have quantum safe algorithms, for the signatures and also for key exchange and all those operations that are necessary too. So this is where we're trying to get to. So let's try to talk about situational awareness and being aware of what crypto primitives and what crypto services you're actually using in your environment. because this will help you whether you're on your journey to quantum or if you're in a place where you're trying to figure out compliance and saying, hey, I know that I'm using strong keys. Maybe you have to prove that you're using strong keys. And so the different features that we'll talk about here will help you with that as well. So one of the main concepts, and you see the title is about situational awareness. It's about being aware of the current situation you're in, and that includes being aware of, your crypto and your security environment. So specifically, as we look at Z16, we want to be aware of cryptographic operations, what you're using today, and then maybe what you want to move to in the future. So we need to have like that understanding and that the sight to see what you actually are using today. It is not necessarily one of those easy things to do, but we have some tools now that do make it much, much easier. So some of the questions that you might ask yourself when you're trying to figure out, where things stand is, well, which crypto was invoked, right? Let's say you're trying to meet PCI DSS, Payment Card Industry Data Security Standard, and they say that your PAN has to be protected, and you can protect that PAN with strong cryptography. Well, what is strong cryptography? Is z16, is that considered strong today? Any answers in the chat? What do you think about z16? Strong or weak? And I will ask you guys questions, so don't think you can just sit there and not answer. So I'm throwing it out there to make you guys work a little bit. Okay, I see some responses there. Yes, weak. Yes, z16 is definitely a weak algorithm. So we'd want to know exactly. Yes, thumbs down for sure. You definitely want to know if anyone's using z16, because you need to start moving to something stronger, right? What about AES 256? What do you think? Strong or weak? See, strong there. Yes, strong. Yes, absolutely. Yes, AES 256 is considered a quantum safe algorithm. And so, yes, we would like you everyone, all of our organizations and industries and just the world moving to those stronger algorithms, because there's this risk that's coming, is that these quantum computers, as they become more and more powerful, the algorithms that were once considered strong today, like maybe even AES 128, may be strong today with a classical computer, but in a quantum world, that would be considered weak. So, okay, so we have compliance. So we need to know which crypto was invoked. What about the frequency of crypto utilization? That's an interesting one as well. How much crypto are you using? I don't know if any of you guys have Crypto Express adapters and you're looking at your system. You're like, okay, well, how many Crypto Express adapters does it support? Okay, I get that. Well, how many do you actually need, right? And how many you need depends on which operations you're performing. And it also depends on what, workloads you're running. How much are you using? Also, which configuration you need. Do you need more accelerator? Are you doing those RSA handshake type operations? Or are you doing operations that are using elliptic curve and you need to have that Crypto Express, as a CCA, a CCA coprocessor? So these are some of the things that you will probably wonder in your environment. How many Crypto Express do you need? Another one, this is a big one. There's many people that are new to crypto, right? Not everybody you haven't probably been doing crypto since you were a toddler or a child or a baby. So there's a lot of people, whether you've been in the industry for 1 year, 1 month, 1 day, 10 years, you're trying to configure and make sure that your environment is in the strongest possible state. And in that case, you may have made a change to your environment and you're like, yes, I set it up and I think everything's perfect. I'm sending my operations to the Crypto Express. Well, are you sure you're really sending it there? What can you use to actually be sure that you have that proper configuration? And so the data that we're going to talk about today with crypto usage is going to help you answer all of these questions. But as you guys know with me, I always try to make sure I take you guys on the journey with me. So we're going to start looking at pervasive encryption, high level, we're going to look at the stack. And now this is going to be a little different approach than the session we did earlier, is where we started at like the very top, and then we kind of slowly went down each level until we got to the algorithms. And then we were able to kind of create that picture around the skyline. This will be a little different, where we're going to look at the stack. Really, we're not focusing on the crypto algorithms and fundamentals so much as we're focusing on the different technologies and how we go about determining what crypto is being used by those different technologies. So you'll see a little bit of overlap and a little bit of difference there. Okay, so let's get back to our favorite chart with pervasive encryption. You guys will have seen this chart so much today that you're going to have it memorized and implanted in like your head at this point. You're going to be going to sleep and dreaming about this chart. But the idea, of course, is that pervasive encryption throughout your enterprise, you're trying to make sure that your data is protected, whether it's in transit or whether the data is at rest, whether it's in z/OS or whether it's in Linux, sitting on disk, or in any other operating system. You're just trying to make sure that your data is well protected. And from a z/OS perspective, we have this z/OS stack. And essentially with that stack, this enables us to do those different operations like, doing network security or data set encryption. Or if you have encryption with DB2 or the RACF encrypted database that you're going to hear about at the session right after this one. There's all of these different capabilities that are available, and the underlying technology is kind of what you see here, like ICSF for z/OS. It is essentially your middleware layer, giving you access to different cryptographic engines that are available. And there are many different crypto engines. So there isn't just one. There may be one kind of key service, the hub is ICSF, but you'll see in the chart that there's many different ways to actually do crypto. So here we have the CCA architecture. That's the IBM proprietary architecture. It tends to be used for financial transactions. You'll see it used for like data set encryption. This is the CCA side has two key stores, a symmetric key store for symmetric keys like AES and DES. And then you have your asymmetric key store, the PKDS, and that's where you'd have like your RSA, elliptic curve, dilithium. Those would be in a PKDS. For CCA services, there are kind of like two main engines that you can use, crypto engines. There's, your crypto express adapter right here, configured as a CCA coprocessor. And you also have CPACF. And CPACF is available with every, Z. It's part of the core. It's there. You have it. Use it. PKCS11 architecture. This one is kind of the one that was owned by RSA, now owned or managed by Oasis. It's a different architecture, different set of APIs and libraries. It has its own key store, our TKDS, token data set. And it has many different, crypto engines possible. So it can use the Crypto Express adapters, of course, but it can also use software crypto. It can use CPACF, right, in the Z system. And it also can make use of your CCA coprocessor as well. So as you can kind of get a feel, if you're trying to go and identify what crypto you're using, there's many different places where you could actually be running crypto. And so we're going to kind of understand, like, how do you piece that together and come up with a story of which crypto you're using? If you need to, for example, prove that, hey, you're using AES 256, how do you go about saying, yes, I know for sure that's what I'm using in my workload? So let's start with our crypto technology, which is CPACF, CPSS for cryptographic function. This is available every processing unit. Now you do have to enable it. So there's a no charge enablement feature 3863. And that's really because of, geographic restrictions and export controls and those kind of things, but it's no cost. Enable it, turn it on, gives you strong crypto. You can see here that it supports many different algorithms. It supports DES, triple DES, AES, and you can see like the hashing that it supports. Random number generation, for those of you who remember my session, I was talking about how symmetric keys are created from random numbers. It does message authentication. And what's interesting is before Z15, CPAC-F only did like symmetric operations. It didn't do like no RSA or elliptic curve or any of that. But if you do have Z15 or later, and this is kind of like when you're thinking about, moving from like, moving from RSA to elliptic curve, and you want the speed of CPAC-F. You see elliptic curve digital signatures, key exchange. You can see those algorithms and are now supported on CPAC-F. And one of the things to think about with CPAC-F is it's super fast, but there's a trade-off for the speed. Anybody want to throw out a potential answer in the chat of, we know CPAC-F is awesome, we know it's super fast. What is the biggest trade-off of using CPAC-F versus like the Crypto Express adapter? Anybody want to throw an answer? No private key support? I guess that's it. You kind of got that one too. There's another answer for Leap, like not a secure key. Yes. The synchronous and thus spin CPU. Yeah, that is true. It does cost CPU. So actually, let me kind of dig into some of those answers. So biggest thing to remember with CPAC-F is that it's going to be like clear key operations or protected key operations. There are no master keys associated with these operations that you're doing. So all of this is in the clear. So if you have a compliance regulation that asks if you are using encrypted keys, it could be the case that you're doing CPAC-F and you could be doing that with clear keys. Now there is the concept of protected keys, and protected keys are keys that are wrapped by an LPAR specific wrapping key that's stored in HSA. So it is inaccessible to the operating system, but it's not the same as having like a master key on a tamper responding hardware security module that's been certified. So it's kind of like there's different levels here. So you see CPAC-F used for like a lot of super fast operations. You'll see protected key use. Generally what you'll have is you'll have your secure keys and you can rewrap them to be protected keys to work with CPAC-F. But we don't necessarily recommend you taking a clear key and then converting it to a protected key and then using that with CPAC-F. You could, it will work, but you won't have your persistent key will still be clear. And if your regulation or your control says you have to use strong crypto and the keys need to be protected, then having your key start as a clear key would still would not be ideal. So you want to have those secure keys. There's another comment here about synchronous and thus spin CPU. That is another truth about CPAC-F. It is using your CPU versus when you're using the Crypto Express adapters and you're sending your crypto operations there, it's offloaded. And so any of the operations that are occurring on the Crypto Express, that doesn't cost in terms of your CPU utilization. Now, of course, the path up to get there, like you're calling ICSF, and ICSF is going to create, this request block and send it across. But once it lands there in that Crypto Express adapter, then all the operations are offloaded, and so it doesn't count for your CPU. And then to Philippe's comment about private keys. So we have the elliptic curve support there, but yeah, it is very limited support for asymmetric operations in CPAC-F. But yes, great, thank you guys. Okay, so let's look at your Crypto Express adapter. Now your Crypto Express adapter is tamper sensing, tamper responding, and its goal, so what it can do is it can really, really strongly protect those cryptographic keys, right? When you're loading your master key, you're loading them onto this tamper responding hardware. This hardware it's certified. When you think about like FIPS certification, PCI HSM mode, this is a hardware security module, and it has many more algorithms that are supported, whether it's clear or secure. Well, generally clear, you'll probably do it on CPAC-F, but there's many more algorithms. You have the secure key support. You're going to have unique operations, particularly maybe, financial industry, PIN generation. There's so many things that you can do with a Crypto Express adapter. However, it has a trade-off as well, right? Anybody want to throw out, like, what is the trade-off with the Crypto Express versus the CPAC-F? I give a second to see if people can think of like Just chargeable feature. Yeah, that's true. It does cost. Yes, the Crypto Express will definitely cost you money. It definitely is not like it doesn't come necessarily with Z. And yeah, and that's absolutely right. It's slower. It's not slow. It's not that it's slow. Like you're talking like it can do like 10,000 operations in a second. But comparing to CPAC-F, which could do like hundreds of thousands in a second, yeah, it's slower. And a lot of that's due, like, you have to call ICSF, and you have to do the IO, and then you have to go to the Crypto Express, unwrap the key from under the master key, do the crypto operation, and then kind of like send the data back. Longer path length, definitely not as fast. It's fast, but CPAC-F is definitely going to be much faster. So you kind of think about these as you're looking at your crypto operations and what you want to do. You get a lot of really strong security on the Crypto Express. You get a lot of speed on CPAC-F. And the reason protected key came about, which is kind of something in the middle, is that it gives you the stronger security than a clear key, but it gives you the speed of using CPAC-F. So it's kind of like protected key is kind of like you either start with a clear key or you start with a secure key, and you can create a protected key from that. And then your operations can be super fast. We strongly recommend starting from secure keys to generate the protected keys, of course. Okay, any questions on that so far? Okay, so now let's come up a little bit. So let's look at ICSF. As I said, ICSF has the two different architectures. There's the common cryptographic architecture, and there's the PKCS11 architecture, and each one of them has their strengths. CCA, as I said, is IBM proprietary. It has many different cryptographic algorithms. Most of the standard crypto algorithms are available on CCA. It also supports financial services API. So if you're talking about, I think someone had mentioned TR31 and TR34, and you're looking at maybe DK10 or derived unique key per transaction, DuckPut, any of like diversified key generate, all of those things that you would use for financial, you're probably going to be using CCA side. They have a lot of custom APIs and libraries for doing financial crypto. To note, if you are writing applications that are using CCA, in your head, there's some cool naming conventions that will help you kind of differentiate CCA from PKCS11, because they're both in the same application programmers guide for ICSF. So if you see CSNB, CSNE, CSND, CSNF, pretty much CSN, then you're going to be on the CCA side of the house for the most part. It has those two key stores, the CKDS and the PKDS. On the PKCS11 side, all of those APIs all start with CSFP. And so all of the PKCS11 APIs will have that prefix. And it only has one key store, which is the token data set. And PKCS11, it really has standard crypto algorithms, nothing specifically for financial. But you can, of course, weave together the basic crypto algorithms to do what you need. But it does have the high ability to do porting of code. So if you have PKCS11 code that may be running on like a different system, yeah, it's it's designed to make it easy for you to port that code over without having to make a lot of changes. So it's one of those things where it's very it's nice to have that portability and that ability to make your applications run, whether it's on Z or on another platform. And also the certifications that are associated with it. So you can kind of choose between these two different architectures. Now it's nice that you have all of these options, right? You have like crypto, it could be software, it can be, in hardware, it could be Crypto Express, it could be CPAC-F, and you have these different architectures. But now you're trying to figure out, okay, well, how do I figure out what crypto I'm using? I've got all these options. Like, how do I definitively say, well, this is what I'm using? Well, it depends, right? Let's think about ICSF. So ICSF is kind of like this big piece in the center. So that's your middleware layer. That's great, right? ICSF, if you had ICSF crypto usage, that will tell you everything about anything going through ICSF. Question is, does every ZOS application call ICSF? What are your answers in the chat? Can you guys give me an example of an application that does crypto that may not call ICSF for the crypto operation or for the encrypt or the decrypt? And I know I'm giving you guys tough questions. Like, I guess for those of us in the US, it's like early in the day, but maybe it's in the afternoon for those who are in Europe. Let's see. So for Java, yes, that is absolutely true. Java may not call ICSF for every crypto operation. In fact, I'm sure it doesn't. It has software itself. There's calls to CPACF. Let's see, RACF, KDF, AES, that could call ICSF, but it could also call Crypto Express. I mean, not crypto, it could call CPACF. So homegrown code, yes, CPACF. Data set encryption, right? Data set encryption will call ICSF to get the key, but it's going to call CPACF directly to actually do the crypto and encryption and decryption operations. Same thing, DB2 could call ICSF in some cases, but could also call CPACF directly. So having crypto usage in ICSF is great, right? For those calls that are going through ICSF, but not every call goes through ICSF, whether it's something that you've written. You can have homegrown code, like I said, call CPACF, or it can call ICSF. So what would be nice is that if you can still keep track of crypto usage in ICSF and also beyond. So one of the other things to think about when you think about CPACF specifically, which is available in the hardware, is that by having crypto usage available on CPACF, that means that it's available to other operating systems as well. So like most of my story here talks about ZOS, but what about Linux? So what if you're running ZVM and you're hosting on top of ZVM? So you can also think about that. It's like a different layer of the stack. And so it gives you ability to see things beyond just our operating system or just beyond ICSF. So again, what we're trying to get to is this situational awareness. So what we need is crypto usage data, not just from ICSF, but we also want our crypto usage data from CPACF. And you'll get that now with z16, is that we have the ability to actually do, it's called processor activity instrumentation, where we can actually tell you which jobs, which workloads are doing CPACF, even if they're not using ICSF. So let me kind of like take you through some of that. Okay, so let's see. First thing we want to look at, let's look at compliance. Well, which crypto was invoked? Let's say we're trying to answer that question. And we know there's many different regulations. So there's payment card industry, NIST, CIS. If you're in Europe, you may have GDPR, maybe ISO, and there's other region-specific regulations as well. And as you kind of start digging down into those different regulations and you realize what is required of you, it means that you need to do some collecting of evidence and a little bit of looking around your system to figure out, well, how do you prove that you actually are meeting this requirement or this control? So you're trying to render the PAN unreadable anywhere it's stored. And you decide, okay, I'm going to do that by using crypto. I'm going to use encryption. But you can't just use any crypto, right? You have to use strong cryptography and associated key management processes and procedures. So it isn't like you just get a check if you do DES 56. You got to make sure you're using strong cryptography. And the reason is because if you're not using strong cryptography, if you're using weak crypto, then it can be exploited, right? It can be exploited by an attacker. The idea is you're using crypto not just to get a ticky mark or a check mark. You're using it because you're trying to protect the data. And so you have to make sure that you use the strong protection and make sure that the data is cannot be attacked and there's no vulnerability that an attacker can use to get to the data in the clear. And we had already talked about, the different layers of the encryption pyramid. And let's say specifically you had heard about this data set encryption and you're like, oh, that would be kind of cool. So you decide that you want to take a look at data set encryption and you want to use that to protect, your data. And with that, you're aware with data set encryption, how you can go and it makes use of CPACF, directly to encrypt and decrypt data. And the reason it makes use of CPACF is, like I said, it's for the speed, right? You're constantly writing and reading to data sets. And so You want to have that speed, and so you're using CPACF. So what's interesting with data set encryption specifically, though, is that it uses two different things, right? For data set encryption, it requires you to have a key that is in your CKDS, right? The cryptographic key data set, you have to have the key. ICSF is the one who owns and manages that key. So you do have to call ICSF. So you can't get away with not calling ICSF, but you only call ICSF for the key. So you're doing a key record read, you're retrieving the key out of the key store. And then DFSMS is then going to call CPACF to actually do the encryption. So it calls ICSF, grab the key, send that to CPACF, do the encryption super fast, right? So you kind of have a combination here where it's using both ICSF and CPACF. And this isn't the only capability that does this. You'll see this for like DB2, and you'll see other components that are doing this. Or you may have homegrown code that can be doing this as well. I would say at least homegrown code that could be calling CPACF or ICSF. For Z16, there's the CPACF usage tracking I talked about. There are enhanced SMF records. So we talked about the SMF 1154s for compliance. Now we have SMF 30s, which actually have more detail, specifically about workloads, jobs, and correlation between those workloads and what crypto is being used. And you may say, okay, well, why do you need all that? Well, let's say you're trying to go to your auditor and you're trying to say, hey, my PCI workload is using strong cryptography. Well, how do you know if you have a ticky mark that says, yes, you use strong crypto, how do you know which workload it was unless you have the job information and the user information associated with it? And that's why you need that correlation. It also helps too with the compliance scope, because with compliance, although I love crypto and I want all the data to be protected, from a PCI standpoint, they only care about PCI data. So if every other piece of data in your environment is not protected, PCI probably won't care. They only care about PCI data. So in terms of scope of compliance, you focus on like those things that they are asking of you for that particular audit. Now, as a security person, you're thinking bigger than that, right? You're not just wanting the check mark. You are thinking about securing your entire environment. And from a compliance perspective, being able to pinpoint which job or user is running a workload with a particular type of crypto will help you in saying, yes, it's this one here is PCI, and I know for sure it's using AES 256, for example. So let's take a look at what this does. And I have, originally I was going to do like a live demo, but I have I did screenshots. I think I did these like last year. And some are like from ICSF from a few years back, because ICSF has had support for crypto usage for a while, but the CPACF support is new. But I have the screenshots in here because that way I don't have to worry about any system glitches at 6 in the morning. So well, let's kind of take you through the process. So right here, we're looking at an environment. So this environment, you can see my different systems. And the idea is that I want to encrypt a data set, right? And so what I'm going to do is I want to kick off a process so that I can encrypt a data set. And then I want to be able to see what crypto was actually used to do the encryption. And remember, for data set encryption, that ICSF is invoked to retrieve the key, but the actual encrypt and decrypt happens through CPACF. So ICSF crypto usage won't show me the encrypt and decrypt operation. I have to use CPACF. Okay, let's go. So we're going to go in, look at the JCL there. I'm going to make a change here. So you see here, I have this encrypt job. And essentially what I'm going to do is I'm just going to write some text. So welcome to Z16. So that's all this does, is it's going to write. I've already established and set up the data set so that it's ready for encryption. It's mainly just let me go write some text and then let me actually prove and see if it's actually encrypted, or I say encrypted and how it's encrypted. So I can run the job, and then what I see afterwards is I can go look at the data set and I can say, yes, welcome to Z16. Yes, I have my data is in here. That's great. But I would like to see what crypto I was used, that was used when this data set was written. And so what I can do is I can look at the SMF 30 output. And what we have and what I need to work on, I think I was working with, John Berg from the Washington System Center, and then Scott Ballantyne from the team for supervisor. And so we have like a way of doing the formatting of the SMF30s, but I think we need to create probably a nice way so that you guys can do formatting as well. So I have to take that as a to-do to have a nice formatter. But this is a way, this is a formatter that pretty much is going to look at the SMF30 record, pick apart the pieces of information that we need so we can see what we're running. So we have that SMF type 30. And in here, you can see different pieces of information. For example, here you can see subtype. So here, subtype 1, 2, 3, 4, 5, and you can see when the job started, step in, job in. What we want to see is we want to see that end of the job. We want to see the cumulative data of what was used for this operation. And so we go and we can look at that. And I apologize if this is too long to fit on the screen. So it's kind of like, imagine that it's one long entry, but I just kind of like split it across two different lines because it wouldn't fit in the PowerPoint. But here, you can see here that there's this identifier. You can see here there's a value, and this kind of overlaps. So this 118 here is the same as the 118 here, and this is 2. And what I can get from that, if you go and you look at the principle of operations, function code 16, basically this says this is an encrypted AES 256 XTS mode operation. And here, function code 118 XTS, and this is a parameter, or this is a compute, PCC compute, using again, AES XTS, AES 256, and this is encrypted. So this gives me enough information to know that I'm using protected keys. Anytime you see encrypted coming from CPAC-F, it's not encrypted under a master key. Remember, master keys are not associated with CPAC-F, but it's encrypted with a protected key that was generated from a secure key that's protected by a master key. And in this operation, I can say, hey, I know that this is a strong key, and I know that this is the key strength that was used, 256-bit. And so for any operation that's running and calling CPAC-F directly, you can get this information. You even know how many times it was called. So here you can see, so this was twice, here, this was twice. So all of that information is available for you now in the SMF type 30 records. And this gives you, like, you have some part of this information also in the SMF 1154 subtype 128, but this will give you more information. And you're going to see later how you can correlate this to the workload and the job. And you can kind of see that here too, because you can see like the job name information. But this gives you much more detailed view of what's going on, who's doing it, when they're doing it, and what type of crypto operations they're performing. Okay, now let's take a different view. Let's look at performance, or let's look at the frequency of utilization. How much are you using? So we saw with CPAC-F, what was nice is it not only told you which algorithm you were using and whether or not it's clear or whether it's protected in that case, but it also shows you how many were being performed. So you can see it was done twice. You can do the same thing, or at least some similar with ICSF as well, where you get the number of operations, you know, who it was, and you get that correlation. So for this particular one, I'm just going to switch over and show you the ICSF version, but you can also do this on CPAC-F. So here you see, if you're doing data set encryption, you can use ICSF for the key, and you can use CPAC-F for the encryption. So there's information in ICSF even when you are using data set encryption too. It's not going to be the encrypt and decrypt, but you will see the key part of it being used, and we'll show you that. So ICSF crypto usage statistics has been around since 2017, I believe. HCR 77 Charlie 1 and later. And this is really an operating system level capability. It's in the base. Well, now I guess it's in the base of 2.4 and later. But with this one, you don't have to run on z16. For CPAC-F, you do have to run on z16 because it's a hardware, firmware enabled feature. But for this one, you can use this in the operating system pretty much anytime. I assume most of you probably have COS 2.4. And if not, you should definitely have 2.4 or 2.5. So with this, you have to turn it on explicitly. I'll talk a little bit about enablement later. These counters are correlated again to COS users, job names, and you can use it for different pieces of information. This is an example I'll show you on the next slide. It's a little clearer. So this is a different SMF type. So remember the previous one was SMF 30. That will give you the details for CPAC-F, which is different than the SMF 1154, which is the reference for compliance. So you got to kind of keep all of these separate. So there's 1154 for compliance. There's 30, which is the detail for CPAC-F, requires z16 for that information. And then you have these 8231s, and this is for ICSF. Here you can see we're doing this over a given interval period. You can see user ID, job name, which cryptographic domain you're running on Crypto Express, or at least not for, Crypto Express, and also for ICSF, which domain it's associated with. Here, like I said, this was back 2017, so that was a while ago. But you can see the card, serial number, the CPAC-F was called, AES56, key record read. So you can see kind of what happened during this particular call. There, it's nice, you have that workload correlation, right? Because you need to be able to say, is this PCI, is it not PCI, or maybe there's another regulation that you have to comply with. You need to know which workload you're running. And then you also want to know how many calls you're making. If you're looking at this from a performance or a throughput, or do I need more Crypto Express adapters perspective, you need to know not only who's doing it, but you also need to know how much are they doing it? When are they doing it? Do you need to deploy, more Crypto Express adapters, or maybe you need to change your configuration because you realize, hey, we're not really using, maybe you're using most of your cards for RSA acceleration. And so maybe you decide to change one of your cards to an accelerator so you get more throughput there. So you can make those kind of decisions based on the information that's available in the SMF record. Okay, the last main section before we get to enablement is configuration. So this is the case where you're trying to set up your environment and you're like, okay, you think you got it right. You got the right configuration of the adapters and CPAC-F and the different APIs you're calling, and you're trying to say, okay, did I really set it up correctly? Well, again, you can use these features to help you with that too. So not just for compliance, not just for figuring out how many Crypto Express adapters you need, but also just verifying that you configured everything the way you should. Because as we talked about before, right, there's a cost associated with where you run your crypto. If you run your crypto operations on the Crypto Express, then there's no cost from a CPU perspective, right? But if you're running the operations on CPAC-F, then there will be a cost of using it. So you might say, well, let me offload these particular operations. Like maybe having, hundreds of thousands per second, maybe, tens of thousands is enough. So you say, I can run that on Crypto Express, but if you didn't configure it properly, you may still end up running on CPU and you wouldn't know it. So this is meant to help you as well, where you can actually identify and say, yes, I know I'm running the correct job, the correct workflows in the correct place. So again, going back to data set encryption. And I think for this one's more, I think it has a little bit of not just data set encryption, but also ICSF initialization. So here you see where I was playing around with ICSF. And this is just me starting it up. I actually wasn't doing, like, CSF EP Charlie 1 is the name of the job, which is just the starter test that I had for ICSF. And so I started it up, and you see it called this card, the coprocessor, as a CCA coprocessor 23 times. I had an accelerator that was called 5 times. CPAC-F was called 43 times. And I also had software crypto here, which was called 10 times. So you can see I'm using like quite a bit, or at least ICSF is kind of playing like under the covers as it's starting up. It's actually going and it's making calls to these cards and doing different things under the covers. Here, and I think I already pointed out the job name, CSF EP Charlie 1, that's sitting on my started task for ICSF. Here you see the cards and the operations. And then here, where I'm actually playing around, and I think for this one, I wrote like a program that was just calling like a bunch of different like PKCS11 and CCA operations, just so I could see what kind of data would come out. And so here you can see the job name is Isha, because this is probably some recs that I that I wrote that I just ran from TSO. And here you see the card was called 3 times, CPACF was called twice, software was called 7 times. You can kind of see the algorithms that I ran. So you can see I did AES 256, generic secret as part of PKCS 11. I did some hashing, a lot of playing around the system with different services. So one of the nice things I will say with the ICSF side is not only will it tell you what algorithms you're using and sizes, it will also tell you which callable services you're invoking. So I can actually see there's a key generation here, there's a key record delete, key token build, there's a symmetric encrypt, decrypt, creation of a PKCS 11 token, deletion, random number generate, and this is AES key, encrypt and decrypt, HMAC generation, key record create for PKCS 11. So I'm just bouncing around between a couple of the different services. And you can, like I said, you can always tell which ones are, or at least, yeah, I think even here, yes, you can tell which ones are PKCS 11 because PKCS 11 always have CSF 1. And that's like according to like the authorization. So the CSFP is what you'll see for the API library name, but CSF1 is what you see from a security perspective. And so we ended up using the SAF controls in identifying which callable service was being used. And the other one's the CSF, these are the CCA services. So CSF1 is PKCS 11, CSF without the 1 is CCA. Okay, so generally speaking, if you're trying to get situational awareness, as I kind of showed you through different examples of either the ICSF side or the CPACF side, is you kind of need both. Yeah, you're not going to get a full view without having both of them in your environment, because as we showed, there are many examples where you're not necessarily going to be calling ICSF for the encrypt and decrypt, and that's where you have your CPACF. But in cases where you are using ICSF, you do have that information. And also remember that ICSF is the only way to get to your Crypto Express adapters. So if you are using Crypto Express adapters, then the only way to get information about their usage is through ICSF. So you kind of like need to kind of use both of these like together. Now, the last few slides, these are more about enablement. I'll take them, I guess I'll take you through them really quick, and then we'll kind of see if there's questions. Okay, so for CPACF usage tracking, you do have to have this for z16. It's not supported on the earlier Z systems, right? This was a firmware change that they had to make so that they can kind of keep track of the activity that's being used by CPACF. And also actually for NNPA, for AIU as well, they also have activity. The for enablement at IPL, it's pretty much on. When you start up Z16, you can explicitly turn it off. You should not see in terms of performance, we did lots of testing there. But the default is, hey, if your Z system supports counters, it's on. All you have to do is check your SMF30 records and look at the data that's in it. But at any point, if you want to turn it off, you're welcome to turn it off as well. You can also there's commands that you can issue if you want to kind of see like what's on at a given point. If you want to see your IPL information, if you want to see the current state, you can issue MBS commands to see that. And then just taking a closer look at the SMF30 records, we had parsed it out, so you saw a much nicer interface, but the idea is you can see like the function codes here, and then you can see like the number, like here you see 17 times single left des was done. This is a bad thing, right? And this is also clear key. So it's like a clear key single des operation, which happened 17 times. Here, this was a triple des key. At least it was protected key. It was kind of good-ish. It was done 99 times, but this gives you this type of information where you can actually identify and know what's actually happening in your environment. And then as you're trying to transition, whether it's to quantum or you're just trying to prove compliance, you can say, okay, is this what it should be for compliance? Or, yeah, this one's using something that's outdated, or you want to move to quantum. And it identifies, hey, this job is going to have to change, or this configuration is going to have to change so that you can get to stronger crypto. And now that's on the CPACF side. Now for ZOS ICSF, like I said, this has been in there since 2017. With this, you do have to enable it explicitly. So the difference between CPACF and this one is CPACF, it's on, it's already on when you start the box up. With ICSF, you have to explicitly turn this on. You can turn it on dynamically using commands on the operator console, or you can turn it on in your Prime Live member for ICSF, and you can have it on that way. Again, performance was checked on these, and so the performance hit to this should be pretty much negligible to you in terms of your workflows by the way it was designed. There's different use cases. Of course, we talked through some of which engines are being used. You can see peak periods of utilization, who's using weak algorithms is one of our main cases, but there's other ways and other things you can use this data for as well. And again, just harping back to, the data that you now have data for both ICSF, you have data now for CPACF, and it can help you whether you're looking at compliance, whether you're trying to figure out if you have enough crypto express, or if you're just looking at just general, configuration, if the changes take effect. And I'll end with this slide because I want to give a few minutes for questions, is that when you think about Z16, compliance and quantum, where from a securities perspective, we're at the core. And so the CPACF, and then you have the ICSF crypto usage, both of these are enablers helping you with both compliance and also helping you on your journey to quantum. So definitely make use of them. Really cool function that is out there. And if I can answer any questions that you may have, please let me know. Let's see. I see a question. Is there a sample SNF job for type 30? Do you mean like a formatter? Yeah. So I remember I have that. So that's been on my list for a while, and so I need to create one. So if you can, I can't recall if I have my email in here, or maybe Jamie can pass that along.
Yeah, it's in the agenda. So Darren, if you click on Isha's session, click on her name on the agenda, you'll see the email address for Isha there. Okay, great. Thanks very much.
Yeah, thank you. That was a great question. Yeah, I keep meaning to put together a formatter just to make life a little bit easier. I don't think there is, like, I know for ICSF, I will say for the 8231s, we do ship an ICSF formatter. If you go to sys1.samplive and you go to the CSF prefix, you'll see, I think, CSFJ and maybe a CSFR, but the CSF prefix, we do have formatters for the ICSF records, but we don't have them for the 30s. So I think we'd have to create something. I don't think we have anything today. I'll have to follow up. But yes, that was a great question. Let's see. Where does compression come into this picture? Oh, yeah. Okay, so I'm gonna ask you guys a question. So is it better to compress data before you encrypt or after you encrypt? Any takers to that question?
Well, you know how useless I am. I would say great crypto, but I would say afterwards.
It's meant to be fun. No, I mean, it's a throw out any answer, so no judgment whatsoever. Okay, looks like we got one answer in there for before. So the before is the right answer. So what happens with encryption, as you guys probably notice, if you play around with encrypted text, it looks kind of like randomized, right? It's like, if you could find a pattern in the data after it's been encrypted, that tells you that the encryption was really bad. Probably not very effective. So generally speaking, you want to compress before you encrypt, so that way you can recognize patterns, and those patterns can be used to do more effective compression. You could certainly apply compression after encryption, but it probably is not going to find enough patterns or anything to make it worthwhile. So we always say to compress and then encrypt. And so that means that when you're going through this process, and I think there's a few different ways. I know at one point we had like the ZEDC. I think that went away with Z15. But I think in most of the ways that you can configure the environment, we do the compress before we do the encrypt, because that you're going to get the best cost savings from the compression. And then also from the encryption, right? Because if you compress it, then you're encrypting less data. So you actually save from the, CPU side as well. So yeah, definitely compress first. And let's see, what is compression coming to? Yeah, so you're going to compress first, and then afterwards you're going to encrypt. And then the crypto algorithm that you're going to use, you're going to get that from the crypto usage information. And the question is it in the crypto community blog? The SMF, well, maybe I should probably be more specific, the formatter. Oh, okay. No, I don't have it out there in the blog. I really should put something out there for SMF 30. Now I need to put that on my to-do list, but no, right now there isn't an SMF 30 formatter out there on the crypto education community. Although that is a great lead-in to tell you guys that there is an IBM crypto education community. You can do a quick, probably Google search on IBM crypto education and you can find it. And there are a lot of code samples, links to documentation, blog articles, things like that, anything about learning crypto. It's just, we don't have the SMF 30 formatter. So I have to take that as a to-do to create a formatter to make it a little easier to process that data.
And Darren, I've just sent you a private email with, private chat with Isha's email address, but your profile doesn't have your email address in Isha. So you might want to log on to my, my GSE, and then you can put it in, and then it will display.
I'll put it in the chat too, because I don't,
okay.
I used to put it in my decks. And I think that I probably did. I forgot to stick it in this one.
There you go.
Z16 comes with integrated compression. Yeah, it's just pretty much the follow-on from what was in Z15. So before Z15, you needed the ZEDC, right? Those adapters for the compression. But with Z15 and later, the compression is integrated. So I think that they announced it as kind of a pervasive, like we have pervasive encryption for like Z14 and later. And then with Z15 and later, it's like pervasive compression. So pervasive encryption, pervasive compression. And if you have more questions on the compression, let me know, and I can put you in touch with Ceci Carranza-Lewis. She's our DFSMS expert, and so she would know more details about how to enable it and making sure that it's running and compressing before encrypting as well.
All the questions are coming in, Isha, another one.
I like questions. Okay, this is perfect. So yeah. Oh, thank you, Philippe, for posting the link to the crypto education community. Thank you so much. That's perfect. Let's see. Are this SMF 30 record compatible with the Siemens adapter? That I'm not familiar with the Siemens that adapter. So let me take a note on that to follow up.
Seam adapter, is it? Oh, okay. I thought, yeah. So yeah, like a key radar or a Splunk or
security intelligence. Monitoring. Okay, SIM. Okay, I thought it was like okay.
I was trying to think that I couldn't remember a SIEM called Siemens, but I think I know what Jason meant. Yeah.
So yeah, I can follow up and see. Okay, for SIM, let's see. I have to talk to Hans to see if Z-Secure is pulling in the 30s. I remember like we did let him know, but I don't know if it's in there. So let me follow up with him, Z-Secure Curator, to see if it's pulling in the 30s. Yeah, great question. Let's see, and let me have the contact info for compression. Oh, now I'm gonna put Ceci's email on blast, but she's used to it, so she'll be fine. So this is for DFSMS architect. SMS architect. And she would also be able to point to compression information. Okay, yeah. So there's the information for Ceci. And feel free to tell her Isha was broadcasting her email. She does a lot of presentations as well, so I'm sure she's just as used to it. Do you need to have hardware instrumentation service active for your crypto counters? That's a great question. It's actually independent. So one thing that was interesting when we were looking at the support for the processor activity was there's an existing support called CPU MF, and that makes use of hardware instrumentation service. And what we found with that one is that that particular one, it kind of was like intermittent. It didn't give you all the information all the time, and it didn't have any workload correlation, and it also didn't tell you whether or not it was clear or protected. So this is completely independent of whether you use HIS. But great question.
Excellent. Well, Isha, thank you so much for taking us through that presentation. Like I said, one of the things I like the interactiveness, you know, and I loved some of those screenshots that you put in. It makes it much clearer. But like I say, I'm not the world's best crypto man, so
You will be now. Now you're going to be the expert.
yes, you'll be testing me like Miss Choi. She always tests me afterwards, but. But anyway, folks, I've just put the link to the feedback for Isha's session. So this is 7p. So if you could please do that, I'd be very, very grateful. Isha, once again, thank you so much for coming to do 2 back-to-back presentations for us. They're really, really good updates. Thank you. And we haven't kind of done with the crypto theme because Mark Nelson will be up with us in just under 30 minutes from now at 3:30 UK time to talk to us about the path to an encrypted RACF dataset. So hopefully you'll be able to join us for that. Isha, have a wonderful breakfast because I know you haven't had any yet. And for the rest of us, it's afternoon tea. And we'll see you again real soon. Thank you very much.
Yeah.
Thank you. Take care. Bye.